Hello, the next web. And I don't want to cry. Get it? Wanna cry? Yes. It's been a pretty busy week for me and my colleagues over the WannaCry epidemic. Because WannaCry is an unusual case. It is the single largest outbreak of ransom Trojans in history. We've seen ransom Trojans for a couple of years. First modern ransom Trojans maybe 5 years ago. And they've been a major headache. But they've never before infected such a huge amount of computers in such a little time. So what exactly was going on here? Why did WannaCry become such a big headache for us? Well, the reason was that it was exploiting a vulnerability which existed in all versions of Windows, all the way from Windows XP to Windows 10. And this particular vulnerability was weapons-grade vulnerability because it was developed by a government. The vulnerability was developed by the National Security Agency of the United States. It was stolen from the National Intelligence or National Security Agency by a group which is believed to be linked to Russian government, and it was leaked publicly earlier this year. And now an unknown group took the actual exploit and implemented it as part of a ransom Trojan. The fix was available. Microsoft had patched this vulnerability already in mid-March, but now we clearly saw which companies patched their systems and which companies did not. Let's have a look at the spreading speed last Friday. Here's a chart showing how it goes around the world. This data is collected by Malware Tech, and this animation is done by New York Times. And you'll see a massive spreading speed in just a couple of hours, very similar to the spreading speeds we used to see with traditional malware, with the web worms from 2002 and 2003, worms like Blaster and Slammer and Sasser. But the big difference here was that it wasn't only spreading, it actually dropped a component on those computers, and that component encrypted your files and then demanded a payment if you wanted to get your own files back. And the business model of ransom Trojans is fairly obvious. For years and years, criminals online have been making money by stealing information and then selling that information to the highest bidder. The change in ransom Trojans is that they realized that for many types of data, the highest bidder for the data is the owner of the data itself. For example, when you steal medical information, it's actually not that easy to sell it to someone else. But of course, the hospital where you stole it from really needs that information. And talking about hospitals, one of the first high-profile victims of WannaCry on Friday was the US healthcare system. Here's a tweet of ambulances crowded outside of a hospital because of computer problems inside the hospital. And we saw plenty of examples of different places getting hit by WannaCry on Friday. WannaCry is really easy to spot because most malware today doesn't show itself. If you get hit by a banking Trojan, it doesn't tell you that you're infected by a banking Trojan. It steals money from you instead. If you get hit by a keylogger which steals your password, you don't see anything. But when you get hit by a ransom Trojan, you get a ransom message. And we started seeing these ransom messages in different places, invisible places. Like here's a clothes store, and the display on the door has a ransom Trojan message. Here's a fuel pump infected by WannaCry. Here is, I believe this is a mall display telling you where different shops are in a mall, and it's hit by a ransom Trojan. Here's a row of ATMs in China. Every single one of them is locked by the ransom Trojan. And here's a city center display in Bangkok. And I guess this is my favorite. This is from a car manufacturing line of a major car manufacturer. So when computers inside factories are stopped by a ransom Trojan, indeed it gets very serious. One more example. This is a train display system at the Frankfurt station. And I know what you're thinking, that okay, yeah, it's hit by a ransom Trojan, but that's just a display. I mean, it's not too serious. What would be much more serious would be that if the train control centers would be hit by a ransom Trojan. But this is just a display. Well, here is a train control center. So what is really going on here? What's the mega trend behind these modern ransom Trojans? And the reason why I keep saying modern ransom Trojans is that we saw the very first ransom Trojan in 1980s, 1989. I actually have it with me right here. It used to spread on floppy disks. Like we actually saw these already in the 1980s. But back then, ransom Trojans didn't get very far, and the authors were caught because we could simply follow the money. For example, the very first ransom Trojan asked you to wire money to a PO box in Panama, and the author of that Trojan was caught simply by following the money. So the change in modern ransom Trojans is that now they have a way of getting the money without getting caught. Cryptocurrencies, especially Bitcoin, is the megatrend that made ransom Trojans and other types of ransom attacks possible. Because we're seeing attacks where, for example, an online store is taken down with a botnet using a denial of service attack, and then the management of the store gets a blackmail note asking them to pay Bitcoins to get their site back up. So it doesn't have to be Trojans that are utilizing these online payments and cryptocurrencies to collect their ransom. So does this mean that Bitcoin is bad? Well, no, it doesn't. Because Bitcoin isn't bad. Bitcoin is a tool. Just like cash isn't bad. It's a tool. And yes, cash can be used for good or bad. Bitcoins and other currencies, other cryptocurrencies can be used for good and bad. Now, I don't actually believe that Bitcoin will change the world. But I do believe that blockchain will change the world. I think blockchain is a much bigger innovation than Bitcoin. Invented by the same inventor, Satoshi Nakamoto, who, as we know, doesn't exist. I once saw a guy with a t-shirt which said, "Satoshi Nakamoto died for our sins." I like that shirt. So the real innovation is blockchain. And blockchain is one of those innovations which, once explained to you, seems obvious. Like what's the innovation here? And that's how you know it's a great innovation. It is obvious once someone invented it, but it wasn't obvious until it was invented. So in a nutshell, blockchain is a public ledger of transactions. And those transactions are locked in place and they can never be changed, which means those transactions will be public forever. And as you might guess, that suits nicely financial transactions, like currencies. But it can be used to do tons of other things. One of my favorite innovations in blockchain space lately has been what I saw from the car electronics manufacturer Bosch. Because they want to fight odometer fraud. Odometer fraud is when you sell your car to a dealer and dealer rolls back the kilometers on your car and then sells it at a better price. Well, Bosch has built a blockchain maintained by a peer-to-peer network of the cars themselves. So the cars maintain the blockchain. And they upload their kilometers regularly to this blockchain where they are locked into place and where they are public for everyone, forever. And that's a pretty neat idea. And I especially like the fact that this peer-to-peer network is made from the cars themselves. Because this nicely solves the problem of how do you maintain this system? How long will it be working? Well, as long as you have these cars on the roads, they will maintain the numbers for each other, even decades in the future. You might even have, you only have 2 cars left. All the other cars have been taken off traffic. But those 2 cars will still maintain the blockchain for each other. And that's a pretty clever, it sounds clever. I don't know if it actually works. But it's a good example on how you can use these innovations to do stuff which has nothing to do with currencies. We're also seeing quite a bit of innovation which joins blockchain to home appliances. And this is the bright new world of Internet of Things. This is the IoT revolution. We have all lived through the Internet revolution. Because during our lifetime, all computers were connected to the Internet. I know it seems obvious now, but for example, when I joined F-Secure in 1991, our office had a lot of computers. We had PCs and we had Macs. Just like today, we have PCs and Macs. However, those computers were not online. And when I say they were not online, I don't mean that they weren't on the internet. They weren't even connected to each other. We did not have a local area network in 1991. So when you were working on one computer and you needed to move documents to another computer, you took a floppy and you walked to another computer. That's the only way. That's the only way we had. So during our lifetime, all computers have been connected to networks, and those networks have been connected to the internet. This applies to computers and, of course, to smartphones, these computers in our pockets. And now the next revolution will be when everything else gets connected to the internet. And everything else will get connected to the internet. If it uses power, it will go online. Anything that we use to plug into the electricity grid, we will be plugging in to the internet grid. And this is going to happen whether you like it or not. And some people don't like IoT. They hate the idea of everything becoming smart. They don't like the idea that, your appliances will now become a privacy risk for you or bring new security worries to your home. So I often hear people telling me that, they're never going to buy IoT gear. Well, that will not be an option. Very quickly, the only kind of appliances you can buy will be IoT appliances. The reason why this is happening is, well, there's two reasons. First, Moore's law. And typically when we refer to Moore's law, we explain how computing power is increasing. It also means that the price for the existing computing power is plummeting. And this means that eventually the chip that you can embed into any appliance, which turns it into an IoT appliance, is going to cost nothing. It's going to cost 2 cents, which means the benefits don't have to be very large. And the other change which is happening is that internet is disappearing. Very quickly we will have internet everywhere on the planet, and any device can always go online without any needs for accounts or subscriptions or anything like that. And this then will mean that in, a decade or so, when you go and buy a toaster, that's going to be an IoT toaster. And you cannot buy a toaster which is not IoT. All right, if that's true, why would a toaster need internet at all? Well, the truth is it doesn't. Like if you have an IoT washing machine, you might get a message to your smartphone that the clothes are clean, which is, somewhat useful. But you don't really need an announcement that the toast is done, right? So why are they going to go online? Well, they will be going online not to benefit you, the customer, the consumer. They will be going online to benefit the manufacturer. Because the manufacturer wants to collect data. Because data is the new oil. They want to collect analytics. They want to know how their toasters are being used. Where are their toasters? Where are their customers? How often do they toast? How often do we have failures? Things like that. And that's valuable information. It's not very valuable, but it's probably more valuable than the price of the chip that they have to put in to turn it into a smart device. So what's the risk here? Well, the risk is that now we are turning all the appliances into computers. And computers have vulnerabilities because programmers make mistakes. Because programmers are human, and humans always make mistakes. So what kind of mistakes? Well, let's take an example. Here's a dishwasher. And this dishwasher has a vulnerability. It actually has a web server directory traversal vulnerability, which means when you connect to the web server on the dishwasher, you can do this get request, and we'll actually be able to steal the passwords from the device. Now, let me repeat the beginning of my last sentence. When you connect to the web server on your dishwasher, like what the hell? And then we have another problem, which is that users, when they take IoT devices into use, they typically misconfigure them, or they don't configure them at all, exposing their admin interfaces on the public internet with default passwords. And this reminds me, of these. Remember these? That's a video player, VHS tape player. This is how we used to watch movies before Netflix, right? In the 1980s. Every home would have one of these. Whenever you would go to your friend's house, there would be a big TV in the living room, and underneath the TV there would be one of these. And every home on the planet had one of these, and every VHS player was displaying the same thing on their screen. Every single VHS player was blinking 12 o'clock on the display. Am I right? I'm right. Why were they blinking 12 o'clock? Because when you buy this device, it doesn't know what time it is, and it expects you to read the manual, because on page 80 of the manual, it will tell you how to configure the time, and we never did that. And we're not going to do this with our IoT devices either. We're not going to change the passwords. We're not going to segment them to different networks. We're not going to set up user accounts, because users don't read the manual. And as we connect everything to the internet, we are also assuming that they will now be getting security patches and updates. But how long will they be getting them? Because when you buy a washing machine, you expect it to work, I don't know, 15, 20, 25 years. When you buy a car, you expect it to work even longer. But how long will it be getting patches? And how long will the cloud backend be there and work? How long will the manufacturer be paying bills for Amazon AWS so that the cloud backend actually works for your appliance? And we actually sort of got an answer for the problems that come out of this cloud connectivity from these devices a couple of weeks ago when Amazon's storage platform was down. I was on Twitter monitoring people as they were tweeting about problems they had with their devices. Like this guy who had an oven on when Amazon went down, and now he can't turn it off. You can't turn off your oven because Amazon is down. What the hell? So I've coined a law on this. The law is that if something is smart, it's vulnerable. So, a smart phone, vulnerable phone. Smart watch, vulnerable watch. Smart car, smart city. Well, you get the idea. So is anybody doing IoT security right? Well, interestingly, a friend of mine 2 months ago was shopping at IKEA, and he bought an IoT lamp system from IKEA called Trojans. And he was sort of chuckling to himself when he was driving home that, he's going to install this and he's going to take a look at this shit. Because it's probably going to be really bad, right? What do you think? It has an app, you can connect to it, you can, turn your lights on and off. But when he actually looked at it, he was surprised. Because it actually was pretty well built. It wasn't running some old Linux kernel from 3 versions ago. It had an embedded real-time operating system, which wasn't running any services, which had no open ports, which was listening to one UDP port, but only accepted authorized traffic, and checked the code signature on all the updates. I mean, it was actually very well done, which I think is a little bit surprising, because you wouldn't think that out of all companies, IKEA is leading the way to secure IoT. But while we have 1 billion new devices getting online, we cannot rely on the manufacturers alone, because most of the manufacturers aren't doing this. We are seeing big problems with the security of IoT devices, and we will not be able to defend them the same way we defend our computers, because you will not be able to install an endpoint security solution on your toaster. Like, I work for an antivirus company. I promise you, we will never be making F-Secure antivirus for toasters. Like, we won't do that. So if you can't secure them from the device itself, you only really have one solution left, which is that you have to secure them from the network. So how do you do that? Well, the solution we have and which some other vendors are planning as well, is building a new hardware device. This is our device. It's called Sense. And the idea is that every home will have one, and it creates a secure Wi-Fi network, a separate network for your IoT device. You have your existing network for your computers and phones, and this is where you connect your smart TVs and washing machines, and then it's going to secure them from the network. This, we think, is the future of IoT security. And we have plenty of problems ahead of us, so we need plenty of solutions. Thank you very much.
Mikko, thank you very much.